Richard Montgomery High School uses a long list of pesticides applied both around the perimeter of the school and in the interior to maintain a secure, safe building. However, because pesticides can have a negative impact on the environment, the use of pesticides must be taken into consideration when calculating the school's carbon footprint. Many negative consequences can result from pesticide use, including accumulation in local bodies of water and the contamination of nearby natural environments. To quantify the effect of pesticides on the size of our school's carbon footprint, we will be investigating the environmental impact of two pesticides used by the school based on the chemical structure and properties of these substances. The two pesticides investigated will be orthoboric acid and zinc phosphide. We will then generate a plan to reduce the size of our school's carbon footprint by improving the current management of pesticide application and substituting environmentally friendly pesticides.
Our hypothesis is if both orthoboric acid and zinc phosphide are applied as pesticides, then zinc phosphide will have a more harmful impact on the environment. We have projected this hypothesis because zinc is a heavy metal and so it is more toxic and will have a greater impact on water quality, plants, and wildlife. RM uses Nabon granular bait, which contains a form of orthoboric acid. The physical appearance of the substance is a white, crystalline solid in a dust form. The chemical formula for the acid is H3BO3 and its molecular weight is 61.83 grams per mole. The acid forms hydrogen bonds between its hydrogen and oxygen atoms. It is commonly used to kill insects, ants, crickets, earwigs, roaches, and silverfish. The boric acid dust clings to the legs and bodies of the insects and acts as an abrasive on their exoskeletons. As the insects groom themselves, they consequently ingest the pesticide, which disrupts stomach function, and as a result, the insects die from starvation and dehydration. Since boric acid is a weak acid with a pH of about 3.8 to 4.8, it is poisonous to an insect's nervous system. An EPA assessment conducted by the U.S. Army's Aberdeen Proving Ground in Maryland has concluded that boric acid is more economical and more effective than pesticides that are sprayed monthly. Only small amounts of boric acid are required, and these small quantities are effective over a long period of time. Also, humans are relatively free of any of the toxic effects that the insects suffer from. A disadvantage of the pesticide is its solubility in water, which allows for greater transport through the soil before eventually contaminating the groundwater. This also makes it more likely for the acid to be taken up by plants, but fortunately the acid does not reach fruit except in non-toxic quantities. However, too much boric acid can have a negative effect on plants by limiting their water absorption and thus hindering plant growth. RM also uses ZP tracking powder, which contains the zinc phosphide pesticide. The physical composition of zinc phosphide is gray tetragonal crystals. The chemical formula of zinc phosphide is ZN3P2. It functions as a rodenticide to kill rodents. Zinc phosphide is part of the class of metal phosphides. All of these metal phosphides are used as rodenticides because they react with the acid and moisture in the rodents' stomachs, hydrolyzing to form pH3, a toxic phosphine gas in this reaction. Phosphine gas in the stomach then enters cells of the heart, lungs, and liver, preventing the production of energy and resulting in the death of these cells. Unlike boric acid, zinc phosphide is insoluble in water, which allows for limited travel through the soil to contaminate the groundwater. However, the phosphine gas that it produces is toxic to the environmental system.
Based on our research of the two pesticides, orthoboric acid and zinc phosphide, our data supports that zinc phosphide is more dangerous and detrimental to the environment. Although most kinds of wildlife will be repelled by the distinct smell of it, as a dust it is indistinguishable, and when it is in the form of a dust, it is the most dangerous. If inhaled as a dust by animals, it becomes highly toxic due to the liberation of phosphine gas in the lungs. It is not only dangerous for animals, but for humans as well. Because it is a heavy metal, it is a stronger contaminant than orthoboric acid. In comparison, orthoboric acid is safer since only small amounts are required, so its deleterious effects are strongly toned down. In consideration of our research, a new pesticide plan would benefit RM's environment as a whole. First, if not already, RM should use limited small amounts of orthoboric acid so its effects don't amount up to it becoming a destructive pesticide. Second, there is a natural rodenticide alternative to the zinc phosphide that can be used instead. which is a cellulose-based product. A cellulose-based product is a natural rodenticide approved by the Barn Owl Trust, and it only consists of natural cellulose derived from maize. It affects rodents' process of food, and because rodents have a unique way of digesting food, other animals who consume this pesticide will not be affected. This pesticide will be much better than the zinc phosphide currently used since it does not lethally affect other animals. In order to ensure the safety of the organisms in the environment while doing its job of killing pests and insects, RM should apply this new pesticide plan. In regards to expanding this research, other pesticides used by RM should be investigated thoroughly to see if there are better alternatives and to see if the application of the pesticides are being limited to its safest amount. This same research can be done for other public places such as parks and other buildings.
During our investigation, we were able to apply concepts learned in chemistry class, such as the effects of certain chemical reactions and properties. The application of chemistry to a real-world problem, such as managing our school's carbon footprint, has highlighted for us the importance of minimizing artificial compounds we introduce into natural habitats, as well as making us more aware of the responsibility we have towards maintaining a safe, clean environment.